Hello everyone. So, yes, of course it is recorded. Are you joining for the first time? Nora, you're joining for the first time. Why? Why are you joining right now? We are already 15 hours through the training. So, I don't think you'll really get much value from this. But do you know our studio earlier? I mean, do you know our? Then it's fine. Then, I mean, it's up to you if you want to join. Uh, After 15 hours, then it's your take. Okay, so let's get started. Yes, can we start? Everyone ready? So, look, please give me a confirmation if you can see my screen. Yes. So, yesterday we had done a lot of visualizations and we had done kernel density plot. And yes, we had to start with line chart or we did line chart. We did line. We have to start with line chart, right? Okay. So, what I'll do is I'll share this data with all of you, height, weight, and months. So basically, this data is showing you the weight and height of a baby month on month. Okay, from 0 to 9 months. I'm sharing this data with you so that you don't have to write it. Now, I want to create a line chart here, right? So I'm going to create a line chart. See, line chart. When is line chart created? Can anyone tell me? Anyone? Okay. Can anyone tell me when is the line chart created? No one? Have you seen line charts? Okay, let me put this in another way. Regression analysis, okay, fine. Have you seen line charts? At least you would have seen line charts. Where can you give some examples of line chart? Can you give me some examples of line chart? Yearly sales, very good. What else? Where else have you seen line chart? Come on, give me some examples. You have forgotten our rule that you have to participate. And you know, I think I discussed that theory with that research with you. The more you participate, the easier it is for you to learn something. Because when you know that you have to participate, you will be, I mean, subconsciously your mind will be very attentive. Okay? So the more you participate, and that is actually the science behind the that when you participate, you learn easily. Profit yearly, okay, Deepak, oh sorry, Alok, it's the same example, sales or profit. What else? And anyone, have you not seen a line chart anytime? Time series analysis is right. Sales and profit is one example. I will take it as one because it's the same context is the same with respect to a company. In general life, have you not seen a line chart? I'm asking everyone, not just Alok. If yes, can you give then give me some examples? Trend, trading, yes, yes. Pallavi, can you elaborate? What do you mean by trading? Isn't have you not seen stock market? Yes, Vishal. Now you. What is stock market? Have you seen bar charts in stock market? Have you seen bar charts in exchange rates? Then why are you not giving me examples? Okay, great. Okay. Have you seen a ECG? Have you all of you would have seen ECG, right? Is it a bar chart? No, it's a line chart. Okay. Ha- Recently, all of you would have seen COVID charts. COVID, yes. What was those charts? Line or bar? Trend line, yes. So then there are so many examples all around you. You just have to be thinking, right? Okay, I can give 10 more examples, but let's cut it short. Now, all the examples that we just discussed, can you tell me what is the common thing around that? X axis had time. Just observe. COVID trend line, ECG. ECG has on X axis there is seconds, milliseconds maybe, right? Time series, stock market, share price, sales, all of these orders on Amazon per hour or per minute or per second or per minute, per hour or whatever. Notice that the common thing in this is that on x-axis you have a time. That is why line charts are many a time they are known as time series analysis, as Vishal just mentioned. Is that clear? Got it? So line charts are primarily created when you have time on the x-axis. Okay. Now look at these, the three variables that I shared with you, right? What do you think will come on the x-axis? Month, right? So we are going to create a line chart, plot month and wait. First I mention month so that first it will take x-axis, then wait, and then type is equal to B. I'll explain what type is. Then everything else you know. PCH, color, main, the rest everything remains same. I'll explain what type is equal to B. It's the type of line. So please write this 389 to 391 quickly. All of you should get a line chart like this. Wherein PCH is 10. I may change the PCH to 1, and then you'll see the line chart changes. 11, 21, actually there are 18 only. So after that, got it? 391. When you're done till 391, let me know. Now, what is this type B? Okay. For understanding type B, let me take you to plot. When you look for details of plot, you will find type. It is a type of plot should be the possible types are P for points. If I want the line to be only points, right, not connected by these lines, I'll mention P instead of B. L for lines, only lines will be there. B for both points and lines will be there. C for the lines part alone of B. Only the line part will be there for B. Then O for overplotted, H for histogram, S for stair steps, N for no plotting, right? So, but mostly that are used are P, L, and B. Okay, so you can try L and see what changes does it make. If I type L and it becomes a line only, right? P is going to generate only points. See, B for both. So most probably you'll be using B only. Okay. Once you're done till 390, okay, I think all of you have done. Very good. Okay, let's create a box plot now. We have seen, all of us know what is a box plot, right? I'm not going to spend time discussing box plot now, right? So quickly get this data using the command data air quality. Data air quality. View this data. Should be something like this. View. This is a data set, I think, for 153 locations in New York or something like that, right? If you want to know more, you can definitely look for air quality. New York, air quality measurements in New York. Okay, 153 observations. Okay. You can calculate structure summary, pretty simple. NAs, look at this. NAs. This is the first data that we are in which we are encountering NAs. Otherwise, we did not have NAs. So notice how NAs will be indicated when you run a summary command. Okay. There in the summary command you will find NAs. Okay. Next. What was the first step you did when you created a box plot? Can you recall the first step that we did? If you can recall, what was the first step? Sorting. Remember? Yes, correct. Yes, Idris, you're right. Sort, right? So let's sort the air quality ozone. I am going to create a box plot for ozone, right? See, you have ozone here. So we are going to create a box plot for ozone. So what I'm going to do is I'm going to sort the unique values of ozone. In line under 408, you'll see these are the unique values of ozone. Okay. After that, I just take a summary of ozone. It comes out to be this. So create a sort the data and summary of ozone. Once you're done till 410, let me know. Okay, great. So those who are done with 410, I want you to tell me the outliers in this data. Let me see who can find the outliers in this data. Quickly, only 1 minute. After 1 minute, I will discuss. Anything above third quartile and below first quartile? No, wrong. Okay, great, great. Vishal, how did you calculate? Can you just elaborate? Yes, very good, Amatullah. Good, Ranjit. I just want you people, those who are still thinking, can you just share how did you calculate this? Good. Those who have done it, very good. For for identifying the outliers, if you remember, the formula for identifying the outliers is any range that falls beyond Q3 plus 1.5 time IQR and Q1 minus 1.5 time IQR. Remember that? Q3 plus 1.5 time IQR. So what is Q3? 63.25 plus what is IQR? Who will tell me what is IQR? 63 minus 18, 45.25 multiplied by 1.5 comes to be 67.25, something like that, right? 67.25 plus Q3, right? 67 plus Q3, 130 comes out to be somewhere around 130. So 135 and 168. Did you get it? Everyone got this? How do you calculate the outliers? Okay. Only a handful of people they respond. That's why I really am not comfortable. Whether people, those who are not responding or not participating, how do I come to know whether they are getting it or not? That's a challenge for me. Okay, fine. Okay, so IQR is 45.25, 1.5 time IQR, Q1 minus 1.5 time IQR, which comes to into the negative territory, and Q3 plus 1.5 time IQR. When you calculate these values, any values lying outside these range are termed as outliers. So 135 and 168 belongs to this category. Okay? Okay. Now creating a box plot, use box plot command and then mention the data, main, xlab, ylab, everything you know, color also you know, only that you have to mention horizontal equal to true. Means the box plot will be generated horizontally. If you mention horizontal equal to false, the box plot will be generated vertically. Okay? So quickly try these. And once you're done till 4 to 8, just type 4 to 8 in the chat window. Sure, I'll scroll up. Is this okay, Ranjit? Good enough? Quickly do it. Thanks for the confirmation, Vishal. So all of you created box plot. I'll wait for two more confirmations. Two more confirmations. Okay, great. Now let's proceed to heat maps. These are some assignments you might want to try at a later stage, right? Heat maps. Do you know what is a heat map? Anyone knows what is a heat map? What is a heat map? Tell me. Those who know what is a heat map, tell me what is a heat map. Used to plot correlation. Not exactly. Even a line chart or a dot, I mean, scatter plot can also help you plot correlation. Okay. It's a data visualization technique. Okay. Distribution based on intensity. Okay. Nice. Color variation used to color. Okay. Denotes intensity. Scale through color. Yes. You are near. At least all the all the responses, you are the closest. A heat map is a data visualization technique that shows magnitude of the phenomenon as color in two dimension. Very good. Kamalpreet. Very good. So Kamalpreet has responded exactly the definition I want. Not, I did not want the exact definition, but at least covered the important points. Heat map. Heat map is uh, gives you the density or the rather not density, intensity of the number, how big or small the number is using the colors, right? Using dark and light colors, it tries to, or using different shades of colors, it not tries to, it gives you a visualization wherein the colors uh, they identify with the values, right? Or the numbers. Okay. So if the number is big, color will be darker shade or maybe a different shade. If the value is small, the colors will be of different shade. Okay. Okay. So let's see how we create a heat map. For heat map, I want you to just view empty cars. Now, when you view empty cars, I want you to take a look on the screen first. We have variables like MPG, CYL, displacement, HP, DRAT, and a couple of more, right? Do you think all of these all of these are on the same scale? All of these are of the same scale? Are on the same scale? No, right? MPG is on a different scale. CYL is on a different scale. Displacement is on a different scale, right? So if I want to create a combined heat map for all these, it will not give me a consistent picture, right? Because displacement will occupy far more space because the numbers are much bigger than compared to others, right? So displacement is going to occupy far more space, right? So to avoid this and bring all of them onto same scale, what do? Rescale the data using the command scale. Okay, this will create a new data set wherein all the numbers will be rescaled, and usually how the scaling happens, usually the scaling happens by this formula. Start working. Usually the scaling is done using this formula. X minus X bar means mean divided by standard deviation. Okay, right? So here now what I want you to do is, after you have viewed and run a summary on empty cars, scale, rescale that all the numeric variables using the command scale empty cars and put it. Yeah, it's normalization only. Yes, correct. It's normalization only. See, I think I missed to read these. In fact, I was coming on this. Okay, since yeah, scaling is the process of standardization of the data. In data processing, it is also known as data normalization, and is generally performed during the data pre-processing step. We need to we need scaling so that we can compare the data coming from two or more different variables, right? I cannot compare, even in this data set, I cannot compare MPG with displacement because both of them are on the different scale. But when I rescale them, right, they are going to come on the same scale and they will become comparable at least. Okay, so quickly scale scale empty cars, and I'm saving it to DF. And when I view DF, notice how my numbers have changed now. All these numbers, do you think now they are comparable? At least they are on the same scale? Yes? Are they on the same scale? Right? So that's what scaling does. Completely change their base and the values. Right? So once you're done, once you have rescaled it, viewed it, create a heat map simply in line number 459. Simply heat map DF. It's going to create a heat map. Notice your heat map would be created something like this. Yes? Let me know if your heat map is created. Type H. If your heat map is created, type H. Okay, great. Right? So, if you look at this heat map, couple of things you will observe that around the heat map there are some lines, right? Some lines, boxes kind of have been created, right? These lines are known as dendrograms, but right now we will not be doing dendrograms because we are going to cover dendrograms in clustering, right? These dendrograms help you create clusters, right? And if you will notice, even for this heat map, you will be clearly able to see three clusters of cars: one, two, and three. Yes, all of you can see similar features. I mean, if you look at the heat map intensity, the three groups that I have created or that I have made you aware, they have similar kind of heat. I mean, similar kind of uh, color scheme, isn't it? Yes, no, maybe, yes, right? This is because of dendrograms. With the help of dendrograms, these clusters have been created. But we are going to learn dendrogram when we do clustering. Okay. So right now, if I don't want to show dendrogram, I can pass this command. I can pass arguments row v equal to na, column v equal to na. Line number 462. Pass this these two arguments along with heat map. Once you do this and run, you'll see now the dendrograms have gone, and you will notice even the clustering is gone. Now the clustering is not there, right? Yes, can you see this? Right? So here again, the darker shades means bigger numbers, lighter shade means smaller numbers. Okay? Okay. I can change the color scheme. See, I can completely change the color scheme using a rainbow color. Let me share this with you. Right? You can try this. Just change the color scheme. Color equal to rainbow 256. This is a color palette. There are more color palettes if you want to look at those color palettes. I have shared the details below. Okay? Okay. So that was about the base R charts. Now what we'll do is quickly we are going to move on to ggplot. You've been hearing a lot on about ggplot. So let's now learn how do you use ggplot package. Okay. So after we are done with ggplot2, we'll give R a rest, and we are going to start with fundamentals of inferential statistics, right? So for that, we are going to give R some rest for till tomorrow second half. I mean second half of the session. Okay. Okay. Everyone ready? Can we start with ggplot? ggplot2. Rest means, sir. Sorry. Rest means, where did I write rest? Ranjit, can you elaborate? You will give, no sir, you mentioned that you will give rest. Ah, rest me. Okay, okay, got it. Rest to RStudio, because we are going to start with, no, no, no. We'll after doing this ggplot2, we are going to shut down RStudio for some time, because then we are going to start with fundamentals of inferential statistics, which will be completely understanding the theoretical concept. Yeah, 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 got it. Yeah, rest to R means we will not be working on R for some time, couple of hours. Okay. Okay, so let's start. Row V and column V, Pungodi. We are not working on hour for a couple of days. Oh yeah, yeah. Couple of till tomorrow midday, just couple of hours, 2 3 hours. Okay. ggplot1 has been replaced by ggplot2. Row V and column V means the dendrogram that you see, right? They are drawn row wise and column wise, right? So if you don't want them, you mention row V equal to false, column V equal to false. Okay? Okay. So let's start with ggplot2. ggplot2 is an updated version of ggplot, right? Written by Hadley Wickham. Again, as I mentioned, Hadley Wickham has been a great contributor to R, right? GG means grammar of graphics, right? GG understanding the advanced graphical capabilities with ggplot, written by Hadley Wickham. It has a steep, or I would say, I will not say steep, but it has a learning curve because there is a different way you write codes when you write codes from GG, yeah, from the ggplot2, right? So there is a slight different way you write codes when you are working on ggplot, working out of ggplot2. So I believe all of you have already installed ggplot2, and maybe you have already activated it also, because we were using diamond dataset which comes out of ggplot2. So I'm hoping all of you have installed it. Okay. Next, ggplot functions works in layers separated by plus sign. Now this is important. How does ggplot works? It works in layers separated by a plus symbol. Okay. So structure of a ggplot code looks something like this. Ranjit, you have not installed the package. It is saying ggplot2 package is not there. Go to packages, check, search here. Do you have ggplot2? Search here ggplot2. Can you see this? Do you have this? I think you don't. Yeah. So then how did you manage with diamond dataset? Maybe then you were not working on diamond dataset? Anyways, so can we continue? Quickly, first install this package. Ranjit, line number 13. Let me share this. Install this package and then run library. Then you will be able to get it. Activate the package. Okay. Either you run library or you run require. They means the same, activating the package. Okay. Now, since we have already worked on diamonds, we know a little bit about diamond dataset. Quickly view structure. I'm going to run structure. Diamonds not found because I did not run require. Run structure and summary. Once you're done till line number 28, let me know. Line number 28, let me know. Okay. So first type of chart we are going to create with ggplot is histogram. So now notice how the structure of the uh, command, right, or the structure of the code rather, right, it is written. As I said earlier, with ggplot2, first thing is you will mention the data. So ggplot data equal to diamonds. Then I mentioned ggplot works in layers, right? Separated by a plus sign. So all these layers work independently. This is one layer. Then I do a plus, and this is the second layer. The second layer is, first I mention the geom underscore history, means first I mention geom means geometry. What is the geometry? What is the shape I want to give? What is the chart that I want to create? Geometry I want to create. Okay, I want histogram. So we'll write geom underscore histogram, right? Once you're done with this, the last thing you have to mention is, see, if I take you here, data, geometry type, and within brackets we mention the aesthetics, right? So here the aesthetics I will mention using the command AES, and within bracket I mention the X axis, right? So X, Y, names, all these are aesthetics, right? Histo underscore histogram means it is a geometry. Okay, line number 33 is clear to all of you. First tell me if it is clear to all of you. So type 33 if it is clear to all of you. You can, I'll give you time to write. I'm just asking if line number 33 is clear. What is happening there in line number 33? I only got one response. So I believe it's not clear to others. Only, okay, I'll explain again. Then why are you so shy? I mean, not shy, but why do I have to repeat so many times before you ask me? Okay, let me explain line number 33 all together again. The structure of the ggplot2 is like this: data, then after data you add the geometry type using a plus symbol, and within geometry I am adding aesthetics within brackets. Is this clear now? Is this clear to all of you? Now I want you to respond at least if it is clear. Okay. So data plus geometry type and within bracket aesthetic mapping. Now let's take a look at the command that creates a histogram. First I mention the data, I add, and then I mention the geometry type using the command geom underscore histogram. Now this is very interesting. See, if I write geom, can you see there are so many charts that you can create? Is this clear? So geom underscore histogram. Clear? Geom underscore histogram is creating the geometry and aesthetics. Within AES, you mention x-axis, x, y, and other aesthetics also. For now, we'll just mention x is equal to caret. Okay. Is it clear now, everyone? Okay. Now, since it is clear, quickly write line number 34, wherein I am creating a histogram. When I run this, what happened? I'm coming to that bin width. Coming to that, just hold on. What happened? Call graphics. Says invalid graphic states. No, it's ggplot only. What happened? It's working. Idris, it's working for you. Yeah, some issue with my maybe laptop. It's working for you, all of you, right? Some issue with my I think system, right? Yeah. So you would have created a chart, right? Histogram. Let me check again. Yeah, that's okay. Sometimes R behaves strangely. Wait. What I'll do is I'll restart R. That I'll come to that. I'll come to that, Amatullah. Just give me a minute, right? Vishal, no need means return the code from line number 34. No need to. Okay. Rerun, but it was not doing it now. Okay, now I got it. I don't know what happened. Okay, so all of you got this chart. and you got a message also in red. It's not a error. This is not a error. Okay, it's a warning message. Okay. Yeah, okay, fine, Vishal. I don't know what happened. Maybe I restarted, it worked, right? Okay, fine. Right? So, what is it saying? Stat underscore bin using bins equal to 30, pick a better value with bin width, right? What is it saying? That there are 30 bins here. If you will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 15 more, right? So it is saying by default it has created 15, by default it has created 30 bins. Okay. Now it's up to you whether you want to take this value or you can change the number of bins by defining the bin width, right? So I am adding an argument bin width equal to 0.5. So this is going to create a, you can see now the width of the bin is 0.5. If you'll notice 0.5. Okay. Similarly, try line number 38. Now I'm taking the bin width to 1 and you'll see the width of the bars have increased, right? I can even decrease this bin width to 0.25. See, okay. So it's clear how you create a chart in ggplot2. First you mention the data, then you mention the geometry, and then within bracket you mention the aesthetics. Okay. Now, can you try a bar chart? Everything remains same. If you see, bar chart starts by importing sales underscore QTY underscore quantity to SQ, viewing it, attaching it, and then creating a bar chart. Once you're done till 50, in which we are creating a bar chart, you can try stack bar chart. Do you know what is a stack bar chart? A bar chart in which the bars show the proportion of the data. The bar chart shows the proportion of the date of the next level of split. Okay. So once you're done till line number 50, stack bar chart can be created by mentioning geom underscore sales QTY not found, sales underscore quantity not found. Shakti, you have not imported it. As simple as that. Now uh, you should try and understand what is the message that is being given. Okay, Shruti, you as well. Okay, right. So What am I doing in line of 55 to 57? Now I can add aesthetics within this ggplot command also along with data name, right? So ggplot sq, then I mention the aesthetics instead of adding after plus later. I can also mention aesthetics along with the data within the ggplot command. Okay, in aesthetics I mention the channel type, then sales cost, and I mention the fill type also within the ggplot. What statement to import? Sales quantity. Are you saying command read underscore Excel, or you can use this import in the global environment? Okay, can we proceed? So we were here, right? Aesthetics. I mention aesthetics within ggplot command and then use a plus symbol and add the geometry geom underscore bar, and I mention stat equal to identity. This is done when you are creating a stack bar chart. Just remember that. Okay. By setting stat equal to identity, you can create a you can just create a stack bar chart. Okay. So quickly do till line number 57. I'll just be back in a minute. Once you're done till line number 57, just mention 57 in the chat window. I'm just coming in a minute. Is it done? Line number 57. Come on, should not take that much time. Done. So once I run line number 56 to 57 and I see the output, it creates a stack bar chart. Okay. And stack bar chart, I'm clearly mentioning it fills the colors as per the pay type. Okay. Fill equal to pay type. Everyone with me? Line number 57. Okay. Once you're done with 57, you run or write line number 64 to 66. The only thing is Dodge is added to create a side by side bar chart. So along with stat equal to identity, I mention position equal to Dodge. Now this is going to create a side by side bar chart instead of a mm, stack bar. You create a side by side bar chart. Quickly do it till 66. Done? Till 66? Okay, 66, 67, yes. Quickly do it now. Now, you can see with ggplot how different the charts are. They are much neatly laid out, beautiful backgrounds, visually appealing charts, right? Properly laid out uh, legends. Can you see the difference? Yes. So the difference between base R and ggplot2 is beautiful backgrounds with grid lines, right? Visually appealing charts. One type of graph can be easily transformed into another. Takes off labels on its own. You can see labels are also taken on its own. Advanced functionality which will be very lengthy with base graphs. So these functionalities you can create similar charts also in base R, but they are going to be created with lot of lines of code. Okay. So now what I want you to do is, see, I told you that ggplot charts can be created in layers, right? So ggplot diamond. Now what I'm going to do is I am just first creating two layers, mentioning the data and the aesthetics. When I do this, I have not mentioned the geometry. So notice when I don't mention the geometry, how my chart is created. Because I did not mention the geometry, so nothing will be created. But still, a background or yeah, the chart will be created, right? Or the background of the chart will be created. The chart canvas will be created, right? So I assign this to G, and Later on, I can add the geometry. See, now I can add the geometry later on. And when I do this, my chart will be created. It will take some time. Okay. All of you got this? A similar chart? Line number 80. After 80, I am again adding another layer, GG title. And with this, I will add a title also. If I want these points to be colored, right? I want these points to be colored. So within geom underscore point, I mention the color coding scheme, right? Within aesthetics, I mention color equal to color means the first color is the syntax, the second color is the color of diamond. So don't get confused there. Okay? So color equal to color. When I do this, my chart will be colored. Try doing this. Line number 86. Once you're done till 86, let me know. Okay, once you're done till 86 or 87, try 90 and 92. Adding shape. Ninety-two. Okay. $92 is done. So basically, I'm adding shape with respect to clarity along with color. Okay. Okay. Quickly, couple of more things. I can seamlessly move from one type of chart to another type of chart if it is possible to create the other type of chart by simply changing the geometry. See, I simply change the geometry and a new chart will be created, right? Geom underscore box plot for caret and color. Sorry, caret and cut. Line number, first I did line number 98 and then 102. So you'll see box plot like these for each cut. Quickly do the till here, till 102. We'll complete ggplot till break and then we'll go for a break. 102 quickly. Okay, once you're done till 102, another very interesting type of chart which goes very well, I mean very similar to box plot is violin chart. Line number 110. Violin chart creates a shape like violin, right? Created by just changing geom underscore box plot to geom underscore violin, right? And look at how the chart is created. Now, to interpret this violin chart, the more the width is there, the more there is width, means there is more density of data at those points. Okay, are you getting it? Violin chart means if you see these lines, thin lines means these there are no data, there is no data here, or maybe any outlier that would be there. Okay, are you getting this? Similarly, I can create a point and a violin together in line number 112 and 13. Look at how it will be created. Point chart and a violin chart. it has plotted the points, right, along with violin. But this is not that intuitive or easy to understand, but jitter with violin is far better. So try this line number 117, jitter with violin. It's going to give you the density in the form of jitter. Jitter means points plotted around violin. So very clearly, jitter with violin gives you a lot of insights, and you'll see wherever the violin is broad, more jitter is there, right? So this is jitter plus violin. It gives you a violin. I mean, gives you much better insights than violin plus point. Do it till 117. Okay. Once you're done with jitter, there is a very interesting chart type that can be created with ggplot, which is called facet wrap, small multiples. Have you seen spark lines? Have you seen spark lines? Do you know spark line chart? They are created in small charts. I mean, in a bigger chart or in a bigger canvas, small charts will be created, right? So just like that, facet wrap creates small charts, and you can create those charts by mentioning the variable with which you want the charts to be divided, right? So what I'm doing in line number 125, very simple. I'm just adding a blank canvas, and then in 26 I am mentioning the geometry with the color and facet wrap it by color. Color here there means the color of the diamond. So you'll see the chart will be created for each color. A separate chart will be created. It will take some time because it will create multiple charts. Am I audible now? Okay, so this is called facet grid, wherein I have mentioned, I have color, caret, price, and clarity. Right? So color, cut, and clarity. Is it okay? Facet grid. Okay, so I think once you do this, we'll take a break for 17 minutes, and then we come back. We can give break to your R studios, and we are going to start with inferential statistics. Okay? Yeah, till 140 only. Yes, you have to do till 140. Fine. Okay. So I'm going to open the poll. Please do participate in the poll. Let us know how did you do in terms of pace and delivery. And the poll is open now. We'll take a 17 minutes break. I'll put up a timer, and please do come back as per the timer. Hello. Uh, Thank you so much for participating in the poll. Please give me a confirmation if I'm audible. Okay, so now you can give rest and close this R Studios. For at least for today, we're going to open it tomorrow now. Okay, now what we're going to start is inferential statistics, right? So now all you have to do is listen. You don't have to do anything else today in the remaining, this part. All you have to do is listen, understand the concept. Very important conceptual part. It is completely conceptual. You need to understand what I'm saying. Okay? Okay. So, what is inferential statistics? We did discuss. Can you tell me in brief? We did discuss in the first session. What is inferential statistics? One, it's a field of statistics that what do we do here? Come on, come on. Hypothesis testing is a technique of inferential statistics. I'm saying what is inferential statistics? Yes, Alok, correct. Drawing inferences about the population from samples. That is what we discussed. Isn't it? Everyone, are you able to recall? Yes, that making inferences about the population based on samples. Why do we do inferential statistics? Because samples. Why do we do inferential statistics? Practically, it is not possible to collect data from each and every member of the population, isn't it? For all the studies or for all the research, it is not possible that we start collecting data from each and every member. Okay? That is why inferential statistics is there, right? And before we start with inferential statistics, I'm going to cover a very important theorem called central limit theorem, which actually is the foundation of inferential statistics. Okay? So we know what is sample and population. I'm not going to cover this. What are population parameters? Who will tell me quickly? Population mean and population standard deviation are known as population parameters. What are sample statistics? Sample mean and sample standard deviation are called sample statistics. Okay. Okay. So remember this. Sample mean and sample standard deviation are known as sample statistics. Population mean and population standard deviation are known as population parameters. Okay. Inferential statistics or descriptive is this. Inferential is this. We have discussed these slides, so I'm just running through these. Now coming to a very important foundation level, you can say theorem, right? Central limit theorem. How many of you have heard of CLT, central limit theorem? Just type C if you have heard of central limit theorem. Okay, Pungori has heard of it. Other than that, no one else? Okay, great. Okay, Alok has also heard. Good. Right? Okay. For everyone, this is for everyone. Have you ever thought of how is it possible that we are able to analyze the samples and then draw inferences about the population? Right? How is it possible? There must be some link, isn't it? each individual has equal chances. That is the that is the definition of randomness, right? Randomness means each and every population has equal chances of being chosen, right? But what I mean to say is, how can I, that, see what you are saying, Amatullah, that is about picking the samples, right? Now, when I pick a sample and I try to, I calculate the mean of that sample, right? From that sample, I'm saying, right? How is it possible that it approximates the mean of population, right? See, if your sample is random, we say it represents population, right? Yes, it represents population. It means that the sample mean approximates the population mean, correct? That, see, if it does not represent the population mean, there is no, I mean, there are no chances that we can draw inferences about the population, right? Since the sample is a subset of population, Vishal, but there are many subsets. There can be infinite subsets, isn't it? Ah, yes, yes, very good example, Amatullah. We only check one or two rice, and if they are cooked, means the entire rice is cooked. Very good example, right? The example is really good. But see, there must be. Now I am talking from a statistical perspective. That how can we see these two are different bodies altogether? One is sample. Of course, it is picked up from a population, but how is it accurately representing population, right? This gap, this link between sample and population is bridged by this center limit theorem. Okay, this gap is bridged by center limit theorem. What does center limit theorem say? First, we'll discuss this, and then I'm going to show you a simulation that will completely blow your mind, and it will give you a very good foundation on inferential statistics. Okay, so let's see what center limit theorem states. It states that given a data set with an unknown distribution, okay, I don't know the distribution of a data set that is given to me, means it is the population, right? Whether it is uniform, binomial, random, or random, right? Like this, can you see? It's a random population, right? No shape, random distribution. Given a random population, right? Now understand this, the one which is written in bold. The sampling distribution of sample means will approximate the normal distribution. What does this mean? I'll tell you. Sampling distribution of sample means. Let's try to decipher this first, right? Means if I pick samples from this population, right? Let's say I started picking up samples of 5. I picked up a sample of 5, random sample of 5, right? And then I take a mean of each sample. Are you getting it? I pick up a sample of 5. I pick up 1,000 samples of 5 randomly. And for each sample, I calculated a sample mean. Okay? Are you getting my point? I want to see. It's a completely conceptual uh, part of the lecture now. If you do not respond, I will not get whether you are getting me or not. But as a part of my teaching, the way of teaching, I will keep on asking. But of course, I also have a limit. So please be responsive. It will save our time, everyone's time. Okay? Okay. So did you get it? What I said? Sampling means, sample means. So if I have picked up, I am repeating quickly again. I picked up a sample of 5. What will be the sample mean? How many sample means will be there? One sample mean, right? No, one sample mean, right? I picked up a sample of 5, na? 5 observations. So what will be the mean of that? One mean will be there. Okay. I picked up 1,000 samples. How many means will be there? 1,000 samples. 1,000 means I picked up 1,000 samples of 5. How many means will be there? Everyone with me? 1,000. Let's keep it interactive. I will keep on asking you questions. The more you reply, the more you will be attentive. Okay. Okay. 1,000 means will be there, right? So can I, if I have 1,000 means, I can create a distribution. I can create a distribution from that. That is what is called sampling distribution of sample means. Is this clear? If I pick up now center limits theorem states that the sampling distribution of sample means will approximate a normal distribution. Okay. Now if you have a population, let's say population has or my data in the population has, let's say, 1,000 observations, right? How many samples of 5 can you pick? Random samples of 5 can you pick? Infinite. If you'll pick up with replacement, you can keep on picking, na? It will be near infinite or a very big number, right? It will be a very big number or infinite, right? So now it's up to me how many samples I want to pick. 10,000, 100,000, 1,000,000, right? If I pick up a huge number and I create a distribution of those sample means, it is going to approximate a normal distribution. That is what it is shown here, right? Sampling distribution of sample means. And if you calculate the mean of this sampling distribution, it will be exactly or very near to the mean of the population. Now this is such a fundamental rule, or you can say such a fundamental result of this theorem on which entire inferential statistics is I mean based. Okay, did you get it? Next, in short, average of all sample means, that is what I'm saying, average of all sample means will be equal to population mean. That is what it is shown here. Average of all the sample means, I have plotted 10,000 sample means and I take an average of that, it will be near or very close to population mean. Is this clear? Second result. Now let me show you these results in a simulation, and it is going to blow your mind, and it's going to, if you are getting it, what is it there, you will be amazed how. Okay, this is a population, right? It was a normal population, right? This is uniform normal, but I will create a very skewed population, right? I can create a very skewed population so that there are no questions around the normality, right? This is my population, skewed population. Yes, I can, from this simulation, I would really encourage all of you to take this link and go back today and try different uh, examples here, right? Try your hands on it. Okay, it says by default n means the observations in sample, right? Let's pick up n equal to 5, right? Means 5, I'm going to pick a sample of 5 from this population. Okay, let's pick a sample of 5. Can you see? And this is my population, this is my sample mean. Is it okay? Did you see the animation? One sample population, one sample mean. One more. Can you see the variation? One sample mean came here, the other sample mean came here. Another one. Another one. Now, if I keep on doing this for 10,000 times, I'm going to create a normal distribution. Okay, let me show it to you. 5 times, 10,000 times. Did we create a normal distribution? Yes. Let's look at the mean of this normal distribution. What is the mean? You will have to tell me. What is the mean of the population? Is it close? Is it approximating? Yes. Let's go and notice this difference between red and green. Sorry, red and blue. Blue is the population mean and red is the sample mean, I think. Yeah, right? So this is the difference. Very close. Okay, let's bring in 10,000 more. 10,000 more. So how many repetitions? 30,000. Let's check the mean now. 13.77, 13.80. Got further close. Let's bring in 100,000. 100,000 more. Now check the mean. 100,000 more. Check the mean. Did you get the fundamental concept? Did you get the concept of center limit theorem? Everyone? Isn't it interesting? Okay, great. So, in short, average of all the sample means will be equal to the population mean. It means, okay, Ranjit says it means sample increases, the more sample increases the accuracy. Yeah, I'm coming to that. I'm coming to that, Ranjit. No. See, there are, that's what I said. There you can pick up infinite samples. Though I will not be picking up infinite sample, but you can of course pick up infinite samples of 5 from this population or not, right? So what 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 it indicates is that if you keep on picking samples, or this is the universe of the samples basically. If you build the universe of the sampling mean of those samples, its mean is going to be equal to population mean. Are you getting my point? I am just trying to emulate the universe of the samples. Is that clear, Ranjit? As the sample increases, the sampling distribution mean got closer to the population mean. Yes. As the sample increases, yes. You are right, Idris. See, that's what I'm saying. Please don't consider as I keep on increasing the samples, but I can I can pick up even more samples. I'm saying even if I have picked up, okay, let me clear it. If I have picked up 5 samples, this does not mean that only 5 samples can be picked up from this. Understand this. If I picked up 10,000 samples, this does not mean that only 10,000 samples can be picked up. You can pick up 1,000,000 samples. As you as you build, as you pick infinite samples, see, the space is for infinite samples. Now, the more you keep picking up, it will be closer to the mean. Of course, you are picking a sample from this space only, no? But it would become difficult to do the research if we have to collect more. You don't have to do it, Amatullah. You don't have to do it. I am showing you the theorem. I'm showing you the result that even if you pick up a sample, even if you pick up a couple of samples, their mean is a part of this distribution. That is what I mean to say. Are you getting my point? If you pick up some samples from here, their mean is a part of this distribution. That is what I meant to say. So when the mean is a part of this distribution, right, there are chances, there are high chances that it is going to represent the population mean. It is because it is part of a normal distribution, right? Okay, still we are halfway around the theorem, right? Let's quickly understand it further, which it gets more interesting now. The distribution of sampling means, sorry, the distribution of sample means calculated by repeated sampling will tend to normality as the size of your sample gets larger. Means if right now my sample size is, what is the sample size right now? What is the sample size? 5. Everyone with Alok, right? Right now my sample size is 5, right? So if I pick 10,000 samples, this is, of course, oh, I did not change the population. Let me change it to a skewed population, right? Okay. If I pick 10,000 samples, right, it is a near normal, uh, it is a near normal shape, right? Now, if I increase this and notice the standard deviation here, what is the standard deviation? 4.31, right? And it is a near normal distribution. Now let me increase the sample size to 20 and I take 10,000 samples. Can you see now the standard deviation? First of all, it has halved. You can also very well see it from here that the width, when I take n equal to 5, the width is very large. But when I pick n equal to 5, sorry, n equal to 20, the width is very small. Are you getting this point? Means n equal to 20. Can you see? Now why is this happening? Because this is the last. The standard deviation of the sampling distribution decreases as the size of the sample that is used to calculate the mean increases. Means, let me show it to you. 5, right? I have taken a sample of 5. First, second, wait, this is not a very good sample. Let me create a very skewed population. Okay. Can you see there is variability? One more will take. Okay, one more. Can you see there is variability? This variability is the cause of standard deviation, right? Now let's see when sample size is 20. One more. One more. Can you see the variability is going to be very less because the sample size is 20. It is the 20 sample size better represents the population than a sample size of 5. That is what I mean. That is what I mean to say. Are you getting this? The variability is so less. 5. See, I've taken 5 more. Within this span, I have again 5 more, again 5 more, again 5 more. See, it is falling, all the sample means are falling within this range. Are you getting my point? N equal to 5. 5, 5, 5. See the variability. Got my point? Right? Everyone got this? So that is why there is a link between sample and drawn from the population because of central limit theorem. Because of this theorem, the samples can be can represent the population. That is why that is what I mean to say. Because the sampling distribution of the sample means approximate the normal distribution whose whose mean again approximates the population mean. Is this clear? Central limit theorem. Okay, so these are some more slides. If you want to go through these, it is exactly what I have explained. These are the slides on that. Okay, now we will come to hypothesis. So it is because of this central limit theorem we can pick the samples from the population and we can draw inferences about the population. Right? There is this is the link between samples and population. Okay. Now, hypothesis. Hypothesis testing is a technique of inferential statistics where we test the claim or the statement of the researcher about the population. Now, what does this mean? It's a hypothesis testing is a technique of inferential statistics. This is clear? Let me start with an example. See, what do you do when you are sorry? What do you do when you are picking a sample from a population? What do you want to do? Tell me. Think. What will you want to do? Research. You want to draw some inferences about the population. Predict. Draw inferences. See, prediction is something when you're forecasting something. Predict, right? You are predicting. You are drawing. You are here trying to draw inferences about the population or analysis, as you can say. You can say analysis also. Prediction also, I'm not saying it's wrong, but it's close, right? Now, since all of you will be after this course, you will be uh, acting as you should start acting as a data science. So you should data scientist or data analyst, right? So you should use the right terms. That is what I mean to say. Okay. So inferences. See, what is the difference between inferences and conclusion? Sorry. Yeah. Uh, Inferences is basically yeah drawing conclusion. Yeah, not difference between inferences and conclusion. See, inferences are you are inferring something based on limited information. You try to infer means infer means if you check the English exact meaning in dictionary, it should say something like wait, let me Google it. I just want to know the infer meaning. Deduce from evidences and reasoning rather than from explicit statement. Yeah, this is what I wanted. It is not something explicit. It is not, inferences means something which is not explicit. You are deducing something. You are concluding something based on some evidences. Correct, Amatullah. Based on some evidences, you are concluding something. Okay, it's not something very explicit. Okay, that is what inferences means. Okay, so what do we try to do from, as some of you said, when I'm picking samples from population, I am trying to prove something. I'm trying to infer something. I'm trying to draw some, I'm trying to prove a claim, or I'm trying to prove a statement about the population. Let's take an example. A very interesting example. Government, they opened open air gym in the last 2 years in a city. They installed open air gyms, right, in a city with the intent that they are going to improve the health of the people living in that city. Right? Everyone got the case? Got the case? Yes? So government in last 2 years, they have made effort. They have installed open air gym. Now, after 2 years, that is now, at present, they, okay, when they installed the open air gym, before installing the gym, they noted what is the average weight of male and what is the average weight of female, right? In that city, the average weight of male was 80 kgs, right? Now, once they've installed the gym, now after 2 years, they want to test the claim. And what is the claim? That installing open air gyms helped in reducing the weight of the male. Are you getting my point? That is how you start constructing a hypothesis. That is how you start building your hypothesis, right? So it is the claim they want to test. Okay, one more example we'll take. In fact, we can take many more, but let's see how many we can take in the interest of time. Mm, all of you know Bormita. Kids love it, and maybe as a kid you would have also taken it, right? Okay. Now, the Bormita company, they want to test that people, those who take, oh sorry, kids who take Bormita are smarter kids. They want to test this claim. Now you will say, how do you measure smartness? Of course, this I am just right now I am just constructing a claim or a statement, right? Of course, it has to be measurable, but right now we are at the first step, right? Another example, let's take. iPhone users use mobile phones more than Android users. Isn't that a claim? This is a claim of a, you can say, claim of a iPhone company, Apple, right? That iPhone users use mobile phone more than Android users because of so reason. Maybe the interface is so good, it looks very good in their hand, maybe the apps are good, whatever is the reason, that is not the concern. Right now our concern is, the claim is that iPhone users use iPhone more than Android users. Okay, one more example. chewing gum, right, strengthens the teeth, right? All these are claims and statements, and many other research statements you would see. I mean, in COVID, there were n number of research statements that we used to hear every day, right, during COVID. Also, okay, let me one more. Mm, okay, the drinking more water keeps you healthy. Doing exercise will increase muscle strength. Yeah, right. All these are claims, right? And all these claims need to be proven before they become a result, or before they become something concrete. They need to be proven. Okay, that thing, that proof can be done using the technique called hypothesis testing. Clear? Is this clear to everyone? Okay. What is the meaning of hypothesis? I'm sure you would have used this term hypothesis, and it is very closer to assumptions, right? Claim or statement or assumption that we make about the population parameter is called hypothesis. For example, again coming back to our open air gym, the hypothesis is that government, the hypothesis from the government is that after installing the open air gyms, male weight was reduced from 80 kgs. Okay, so this is an assumption, supposition, presupposition, supposition, claim, statement. But important thing is, this is only an assumption by the researcher or by the analyst. It is still to be proved. Okay, assumption is he thinks what analyst thinks, isn't it? But it is required to be proven. Clear? And that can be proved using inferential statistics. Okay, everyone, it's clear what is hypothesis, what is hypothesis testing. The problem statement that leads you to some analysis is called hypothesis. Of course, we have taken a lot of examples, right? All of them will lead you to some analysis, right? Problem statement here means that it that means a statement that is significantly different from the as is situation. Now let me explain this also, very important statement, and notice these words in italics, significantly different. Let me try and explain this also. Notice that all the problem statements that I narrated just now, starting from open air gym, right? Okay, again, let's go back to open air gym. Government has a claim, government is making a claim or a statement or an assumption that the installation of open air gyms have reduced the male weight from 80 kgs. Okay, everyone with me? Did you get it what I'm saying? This is the assumption of the government, right? What was the as is situation? What was the as is situation? Male weight is equal to 80. Isn't it? Isn't it? The as is situation means the current situation was. What was the current situation? The male weight is equal to 80. Right? So, isn't the problem statement significantly different from the as is situation? Yes? Right? See, problem statement cannot be the as is situation. Why? See, you will try to prove. the claim or the statement? Will you try to prove something that already exists? Will you ever try to prove that already exists? Do you need to prove that? No. Got it? So problem statement means the statement that is significantly different from as a situation. Clear? The meaning of hypothesis and hypothesis testing. Okay? Let's, this is just a graphical depiction. I'm sure all of you can relate it, right? So we'll proceed. Hypothesis is the first step in designing and conducting the research. Characteristics of hypothesis is it's clear, specific, and testable or researchable. It is a link between theory and research. Okay, that leads to new discoveries. So this is just theory part. Again, another theory slide. Hypothesis statement is a declarative statement, postulate a relationship between variables, reflects a theory, be brief and concise, and be testable. Okay, just you can say some of the characteristics of hypothesis. Okay. Okay. Next. Now there are some different types of hypothesis. You will hear also, and we are going to do those also. Simple hypothesis. When it is when the claim or the problem statement is simply a relationship between two variables, right? One of them is the cause, the other one is effect. Okay, only two variables. Example: older workers are more loyal to the companies, right? This is simply it is uh, creating a relationship between the older workers, means the age of the worker, and the loyalty to the company, means tenure, isn't it? The more tenure you are spending indicates, assume that it indicates more loyalty, right? So only two variables, simple hypothesis. Okay, one of them is independent, the other is dependent. Second, complex hypothesis. When it postulates the relationship between more than two variables. Example: global warming global warming causes iceberg to melt, which in turn causes major changes in the weather pattern. So complex, right? Simple. I mean, understanding wise it's clear. More than, but again, we our focus is going to be only on simple hypothesis, so we won't be doing complex hypothesis. But yeah, this is theory. Okay, next, statistical hypothesis. It's a technique to scientifically test the researcher's hypothesis. A formal hypothesis structure is required. That structure is called statistical hypothesis. Again, a theoretical term. Need not, nobody is going to ask you this. What is statistical hypothesis? Okay. Yes, but the two types of statistical hypothesis, last line, null and alternate. It is from here things start to move towards the practical part, which will be very important for you. Okay. So there are two types of statistical hypothesis, null and alternate. We need to understand that very, very thoroughly. It is the foundation, the build. It is from where you start constructing your research. Okay. Okay. So let's understand what is null hypothesis. Null hypothesis is an assumption about the value of population parameter, isn't it? Uh, isn't it an assumption when about a population parameter? It is usually the assumption with no change. Means I am assuming that the population, that the male weight is 80 kgs, right? It's an assumption with no change as is situation. Some words that resonate null hypothesis or that goes with null hypothesis, null condition exists. Nothing new is happening. Old theory is still true. Old standards are correct. System is in control and assume no change. All these words represent null hypothesis, right? Clear? No change. It's an assumption with no change. Okay. Now, some more interesting things about null. Null must contain the equality symbol. Means when we are going to construct null hypothesis, it will always contain the equality symbol. Either three ways it can contain: mu is equal to 5, mu is greater than equal to 25, mu is less than equal to 150. So either of these can be a structure of null. Only these three, right? Let's let's see in our government installing open air gym example. What is our null? Can someone tell me? Our null was the as is situation. What was our as is situation? Male weight was 80 kgs. No, male weight was 80 kgs, isn't it? That was our as is situation, right? But this is half the story, right? I'll discuss. I'll come back to this example once we are done with alternate, because identifying an alternate hypothesis is much easier. And once you have identified alternate hypothesis, then identifying the null is very easy, right? Right now, at this moment, what should be the null as per you in the male weight case? I mean, in the government case, what should be the null? Tell me. Weight is equal to, oh, who said this? Alok. Alok, very good. So, I know you know it. I can make it out. But what is the null? Most of you will say that weight is equal to 80, right? Yes, weight equal to 80. You are right, right? See, Alok knows, so don't. I'll explain why did Alok said weight is greater than equal to 80, right? But for now, just understand. If I ask you what is the as a situation, you will say male weight is equal to 80, isn't it? No change in the weight, and what was the weight? 80 kgs, right? Okay, so important thing is it should contain the equality symbol. Generally, the researcher don't believe in null. Very, very, very important statement. This is going to help you identify the difference between null and alternate. Generally, the researchers don't believe in null, isn't it? From the example also, male weight example, is the government believing that the male weight will remain 80? Is the government believing that? Tell me. I want answers. Only two or three respond, but good. So notice that we construct the null is not something that is believed by the researcher. Okay? The researcher does not believe in null. What does he believe in? Some change situation, isn't it? Some different situation he believes in, no? Isn't it? What is the fun in believing something that already exists? Okay? Generally, the researcher don't believe in null. The next sentence, let's leave it for some time. Observe difference between sample and population arise because of random chance variation. This, okay, let's not leave it. Observe difference between sample and population arise because of random chance variation. Remember our simulation? Wait. This is my sample mean or population mean 12.24. 11.54. Some significant difference is still there. Again, let me pick another sample. Hmm. This time it would be different, right? So these differences that are coming, they are because of random chance variances, means randomly we are picking samples, and of course they, if we pick only one sample, it will not be equal to, the mean will not be equal to population mean. But if I'm picking these samples infinite number of times, then when I take a average of those means, it will be equal to the population mean. Okay, got this point? Observe difference between sample and population arise because of random chance variation. Okay, and last thing about null is we either reject the null, right? In hypothesis testing, we either reject the null or we fail to reject the null. Okay, we don't accept the null. We either reject the null or we fail to reject the null. Is this point clear? I will, of course, discuss this point in detail, but at least on the face it is clear. What do we do with null? We either reject the null or we fail to reject the null. Okay? Okay. Now, let's understand what is alternate hypothesis. And then I'm going to come to fail to reject. Okay? First, let's understand alternate hypothesis. What is alternate hypothesis? It is what is believed to be true if null is false. It is a negation of null. Now tell me, in the open air gym example, what is believed to be true? What is believed to be true? Tell me. What is believed to be true? What is government believing to be true? Is it equality that is believed to be true? Government is believing that the male weight will be equal to 80. Think and reply. Exactly. The government is believing that the weight will be less than 80. Isn't it? So what now, understand this. It's very easy to identify alternate. Whatever we need to prove, whatever is the claim, whatever is believed to be true, that is alternate. That is, we will put in alternate. Rest everything we will put in null. Okay? Did you get my point? This one statement will help you construct null and alternate without any mistakes throughout your life till the time you are doing this one statement. I am repeating, it is the crux. Whatever is believed to be true, whatever is your claim, whatever is your assumption, right? That is always put in alternate. So in this open air gym, the alternate is weight is less than equal to 80, and rest everything put in null. So can you tell me the null now? Can you tell me the null in the case of open air gym? apart from Alok. Alok knows it, I know very well. Can you tell me the null and alternate both? What is this, Idris? What is this, Idris? Null. Very good. Very good. Null. Ranjit, that is alternate. See, less than is alternate. I said whatever is to be proven. What do you want to prove? That male weight is less than 80. That is alternate. Rest everything is null. Null. Very good. Yes, Amatullah, you're right. Also tell me the null. Amatullah. Ranjit, you are right. Null is less than, sorry, greater than equal to. Null is greater than equal to. See, less than is alternate, na, Ranjit, right? I hope I did not miss anyone else. Kanupriya, male weight is greater than equal to. See, is null. Correct. Kanupriya, you're also right. Right? Idris, as I've seen, Adbisi. Adbisi. Oh, sorry, Idris only. Sorry, my bad. Yeah, it's correct, right? So everyone got it. Whatever is to be proven, put it in alternate. Rest everything put in null. That's it. Crux. Period. Okay. So some words that resonate alternate. New theory is true. New standards are there. System is out of control. Something new is happening and statistically significant change is observed. We'll discuss this statistically significant change. Let's take a look at some more details about alternate. Must be true if H0 is false. Does not contain the condition of equality. Always remember, equality will be coming in null only. It will not come in alternate. Remember this always. Okay. So what are the different types of alternate you can create? Mu not equal to 5, mu less than 25, or mu greater than 25. Is this clear? It's a negation of null. Usually what we are testing. And lastly, the claim we are testing or the initial claim that is to be tested. Got it? That will be put in alternate. Now let me ask you some questions and you will have to, okay, no, so wait. Before we proceed, I still have to cover why fail to reject, right? Why don't we say accept null? Why do we say fail to reject null, right? Its answer lies in the next couple of slides. Fail to reject, right? A little bit confusing sometimes because it looks like a double negative, right? First fail and then reject. Why can't we say accept? No. We never say accept sorry. You said accept alternate. Yeah. Yeah, you can say equivalent to accepting the alternate, but we never say accept the null, right? We say fail to reject the null. Why? Because we cannot conclusively affirm a hypothesis, but we can conclusively negate it. It is something like, what is darkness? What is darkness? It's the absence of light, is darkness. Are you getting my point? Right? We so we can prove that there is light in a space, but we cannot prove that there is darkness in the space. Are you getting it? We can prove that there is light, okay, there are bulbs, but we cannot Darkness is just the absence of light, right? Are you getting this point? Similarly, we assume that null hypothesis is correct until we have enough evidence to suggest otherwise. Treat null as darkness, otherwise to suggest unless we have a, so we assume that the null hypothesis is correct. If we are not able to prove that in a room there is any light, it means there is going to be darkness, right? We will assume that yes, that room will be dark. Are you getting this point? Until we have enough evidence to suggest otherwise. If we are able to if we go to the room and we are able to spot some lights which are on, right? Then we have gathered evidences that there is light in the room. Getting it? All of you are getting it? Fact is that we cannot prove a negative. Same, we cannot prove a negative thing. Negative is just the absence of positive. Okay? A lack of evidence only means that you haven't proven that something exists. It does not prove that something does not exist. It might exist, but your studies missed it. Okay, let me take another example. Have you all seen court trials? Have you seen court trials? I mean, need not be in reality, but at least in movies, right? So why I'm asking, just so that you can relate the example. Okay. So when you have seen court trial and the court brings in the discussion is centered around the guilty person, right? Or the person, or the convict rather, right? So how does the court trial start? Does the judge or does the court says, okay, bring the guilty person? No, they will never say this, right? They will never say this. They will always say, bring the convict, or right, no, bring the person, and they are going to start with an assumption that criminal is not guilty. Always, yes, not guilty and otherwise proven otherwise, uh, till proven otherwise. Yeah, right. So they will start the court proceedings assuming that this person who has been brought is not guilty. Okay, and then the prosecutor works really hard to prove and present the proofs to prove that it this guy is guilty. Are you getting my point? Everyone got it, right? If he is not able to prove that criminal is guilty, if suppose he is not able to present the evidences that proves him guilty, do you think the judge will say, okay, he is um innocent? Do you think the judge will say he is innocent? No. The judge will say this guy is not guilty. There is a difference between not guilty and innocent. Okay? Did you get this point? On that same premise, we never say accept null because we are not trying to prove null. We are trying to prove alternate. Right? We only say either reject the null or fail to reject the null. Okay? Is this clear? Yes. Hamatullah says absence of proof does not mean proof of absence. Yes, very nice. Okay. Is this clear? Okay, now I'm going to give you some examples. You will have to construct null and alternate. Let me see who can do it correctly. Example 1. Quickly read and tell me null and alternate. Remember that one sentence. That is going to always help you. And I'm repeating that sentence just for the benefit of all of you. Whatever we want to prove or claim or assumption, we put it in alternate. Rest everything we put in null. Is this clear? Okay. Amatullah says null is market share less than equal to 23. Company has held a 23% market share of product A. There was an increase in marketing effort, and hence the company believes that its market share is now okay. So there was an increase in marketing effort, hence the company believes that its market share has now greater than 23. So everyone, what is alternate? See, first we will always construct alternate. What is alternate? Give me alternate first. Alternate is greater than equal to. Amatullah, alternate is greater than equal to, right? Right. So rest everything in null. Sorry, alternate is greater than not equal to. My bad. All in alternate you can't put equal to. Remember that condition. So Alok has constructed correctly. Alternate is market share greater than 23. Vishal, why are you saying alternate less than or greater than 23? I am saying what we have to prove. Vishal, look at the example and tell me what we have to prove. Correct, Idris, you are right. Alternate is Vishal again equal to. I told you you cannot put equal to. You can only put equality in null. Vishal, remember that condition? I just discussed that equality will all only be in correct. Null. Why is it greater than? Is it should be greater than or less than? Read the question and tell me. That's what I'm saying. Always construct alternate first, then move on to null. Vishal, did you get it? Null. Again, you have written MS greater than 23. MS should be less than 23. That is, this is Vishal. This is, see, think logically. Don't just keep giving me options. I think you did not understand it. Null means two things. One, equality will always be there. And second, it is something not to be proven or to be believed. Is this clear, Vishal? So you have said alternate is, you have mentioned alternate as MS less than 23, which is not, which is not what it should be. Alternate is something we have to prove. What we have to prove? Company believes that its market share is greater than 23. So we have to prove that the market share is greater than 23. Yes, now you're right. Rest everything put in null. Vishal. So null will be equal to MS less than equal to 23. Okay. Over to example 2. We have to spend a lot of time here. Can you quickly construct null and alternate for this? Quickly. Read through and then construct null and alternate. Very good. I think all of you have constructed it correctly. Null and alternate. Alternate is less than 40, which is to be proven. Null is greater than equal to 40. Very good. Mm, correct. Customer age is less. Very clearly it is given. Okay. So all of you mentioned this. Yes. Okay. Example 3. Can you quickly construct, and notice this is still 100 and then it's a full stop. It's not 100.25. It's 100. So hypothesis is conducted to test if the population mean is still 100. Alternate is population. Who said this alternate? Ranjit. Again, I'm mentioning it again and again. In alternate, equality sign does not come. And again, you are putting equality in alternate. Alok, you are right. Correct. Now, I think most of you are right. So null will be population mean is greater than. Okay. Is it clear to all of you? Null alternate is clear. Spent a lot of time. Why do we do statistical hypothesis testing? We know this. Then I'll just explain what is statistically difference and we'll close for the day. How do we know if the alternate is this or this? In the last example, okay, there is good question. It's like this. The third case. Okay. No direction is given. Got it, Idris? Not equal to. Equality is null. Not equal to is not equal to is alternate. Clear? Okay. So Idris, clear? Right? So now, why do we perform hypothesis testing? Most of you know it's a trade-off between work and sample. Trade-off also trade-off. There are trade-offs to work with samples. Before this, there are a lot of benefits of working with sample. In most cases, it is simply impossible to observe the entire population to an to understand its properties, right? Alternatively, alternative is to collect random sample and use statistics to analyze it. So samples are much more practical and easy and less expensive way of, right? So samples are much more practical and easy and less expensive way to work with, right? Hypothesis testing incorporates estimates of the sampling error to help you make the correct decision. Don't worry, right? So this is clear. Now last thing and then we'll close. What what is this term called statistically significant? See, statistically significant means that some difference, some change has happened in the as is situation, right? We are not doing p values right now. Yeah, I know you're right, Amir, right? But right now, just refrain from any term that people don't know. Otherwise, they'll get confused, right? Okay, statistically significant means that there has been some change for sure. That change may be very small, but it is definitely a change. Let me discuss an example here, right? First example that we discussed, right? Let's go to that example. This one, right? Company held a market share of 23%, right? Now, just think that you are a owner of this company, right? And the your manager or your person who is heading the marketing, he comes and tells you that we are planning to spend 100 crores rupees, 100 crores, right? Or millions of dollars, whatever you want to take, right? We are planning to do this, and our market share will increase from 23 to 30%. Okay, it's a huge market. Maybe in that 7% increase, you will maybe you would increase hundreds of crores of sales, right? So as a owner, will you be willing to do that? Will you be willing to do that? Yes, right? It will increase the market share significantly, 23 to 30%. Won't you be willing to do that, even if it is a big amount? Okay, because you want to grow. You want to grow, na? You want to grow. You are planning to grow in next couple of years. So of course, if there is some plan, you would be willing to do that, right? Okay. Now, when he spent the amount, right? Competition also became aware and they started aggressive campaigns for their own product, right? Right? So the market model changed, right? Competition became aware, they were also spending, and in the end, we barely were able to increase our market share from 23% to 23.1%, right? Got my example? All of you got my example? What happened? Yes? Please respond. All of you got my example? Yes? Initially, the marketing manager expected that the change will be a big one, 23 to 30%, and he will be spending crores, huge amount in marketing. But actually, the result came out to be very small because of competition becoming aware and they also started pushing hard, right? So tell me, as a business owner, would you be very happy with that market share? No, right? Why? Because business always look for ROIs. ROI means return on investment, right? Okay. Now, as a statistician or as an analyst, do you think that change has happened? A significant change has happened? As a statistician, think 23 to 23.1% also. Do you think that change? Why? I am saying don't think. Usually we are in the habit of thinking like a owner, right? As a owner, you will definitely be disappointed because you wanted, because owners are concentrated only on ROIs, return on investment. But as a statistician, now think as a statistician, do you think a significant change has happened? Yes, isn't it, Vishal? Even even a 0.1% change for a statistician is a significant change. Isn't it a situation which is different from the as is situation? Isn't it a situation, even though very insignificant from business perspective, but actually there was a change, right? So that is what is called statistically significant, right? Statistically significant results are not always business significant outcomes. I gave you this example, right? To statistician, the word significant means the result is not merely due to chance or it is different from the as is situation. That is, we can reject the null. Are you getting it? So can we reject the null in this case? In the case of 23.1%, can I say that my null does not exist or I reject the null? Yes, isn't it? Because now the new situation exists. So null, we will reject the null. Even though new situation is very insignificant, but still it is different from 23%. Clear? For statistician also change could be insignificant. No, even the minutest of the day change will be significant. Okay, Amadullah. Change will be significant whether it is a 0.0001% also. Change, any change from the as is will be significant change for a statistician. Is that clear? Okay. To business decision makers, substantive result is when the outcome of the statistical study produces results that are more important or large enough. So what is business focusing on? Either more or large enough or something that is important because they focus on ROI, right? As a business, you focus on ROI, but as a statistician, you don't focus on ROI. You you look whether this you observe whether the situation has changed or not. Is this clear? Statistically significant, right? Last slide, and then we'll close. I've already discussed this, but quickly I'll read. Statistically significant means that the result or outcomes of an event did not happen by chance. I will share it. I will share it. Okay. Did not happen by chance. Like in our marketing example only also, it did not happen by chance. 23.1 did not happen by chance. It it was a planned attack. I mean, it was a planned. Uh, we wanted to increase the market share, and all of a sudden, the competition became aware, and our 30% expectation got reduced to 23.1%, right? So it was something planned. It was not random by chance. It did not happen randomly by chance. Okay? There were proper steps behind that 23.1. Okay? Clear, everyone? Means test results are significant or meaningful. Statistically significant means the test results are significant or meaningful. More specifically, whether your statistic closely matches what value would you expect to find in the entire to find in entire population parameters, means that we have evidence that the results we see in sample also exist in population. This means statistically significant means if I am picking a sample and it is indicating that 23.1%, these results are expected to be representing the population also. Okay? Means that we have evidence that the results we see in sample also exist in population. That is what statistically significant means. Is it clear to all of you? Is it clear to all of you? Okay. How can we decide when it is it has happened by chance? When we fail to reject null. Okay? When we fail to reject the null, see, when we reject the null, I can say that the the change has not happened by chance or randomly, right? But when I know that there has been no change in null, right? But the samples indicate that there is some change. Actually, there is no change, right? In that case, it means they are just random chance variations. Okay? Okay, Amatullah. Okay, then, right? Hopefully, this discussion has built some ground with respect to inferential statistics. We are going to continue tomorrow. Okay? Till then, take care and goodbye. And just do revise what we have done, right? It will really help you if you get time. I mean, I know it's a daily class, so it's difficult, but do take out some time and revise what we are doing. Okay? Goodbye and take care. Already shared that. If not share, I'll share it. Okay? Don't worry, Amir. Right? I'll share it. I'll share it. I'll share it. Okay? I'll just see and then share it. Okay. Till then, goodbye.